So now today we will discuss about the osmoregulation in marine water. Osmoregulation in marine water, right? So basically we know that in marine water the external environment is hypertonic. External environment is basically hypertonic. Consider that basically usual condition in the usual condition we have a fish. We have a fish over here, right? So basically it has the external environment hypertonic, but the internal environment is basically hypotonic, right? But it has less amount of salt, very less it has very less amount of salt, but that less amount of salt is quite high. But that less amount of salt is quite high as compared to the external environment, right? That less amount of solute is quite high as compared to the external environment. So the internal environment, according to this fish, according to this organism, become hypertonic. So water keeps coming inside the fish. Water keeps coming in fish. So basically they feel the flooding, right? So they need to remove this excess of water. So for that purpose they basically pass concentrated urine. They pass concentrated urine. Moreover, for example, the ions like sodium, potassium, chloride, these single ions, these monovalent ions are excreted, are removed by gills, and the divalent ions like magnesium, calcium, these are basically removed by kidney. These are removed by kidney. Moreover, like in the rectum, there are rectal glands. They are rectal glands which basically excrete salt by process of ejection. Which basically excretes salt by the process of ejection, right? This is basically a usual condition of how this water is cooked up. Now basically there is unusual condition as well. There is unusual condition as well, in which, consider this is a fish, the external environment is hypertonic and the internal environment is hypotonic, right? And there's a less amount of salt, but that less amount of salt is basically urea, which is basically toxic, and basically it has a denaturing nature. It basically denatures the protein. It denatures it basically denatures the protein, right? This is the urea, which is toxic, and it has denaturing agent, and it denatures the protein. So for that reason, an other substance is also produced in their body, which is known as TMAO. Basically, TMAO stands for trimethyl amino oxide. Trimethyl amino oxide, TMAO, is produced in their body in order to reduce the toxicity of urea. To reduce toxicity of urea. In order to reduce the toxicity of urea, TMAO is produced. So basically, these both substances, urea and TMAO, are known as osmolytes. Urea plus TMAO, they are known as osmolytes. Why? Because they increase solute concentration in body. So in order to cope up with the salt, obviously there is a lot of salt, urea is also there, TMA is also there, so the body of this fish is converted into a hypertonic condition. So basically the water enters into the body, water enters in body. So basically they also produce, now they also feel flooding. So in order to cope up with this, they produce concentrated urine in order to remove the urea. To remove urea, right? So I hope this is clear to you. If you have any kind of queries, you can ask me in the comment section. I'll be really glad to answer you guys.